If ML Collective is about one thing, it's about open collaboration. We want people to think that science is not, it's not like science can be associated with employment. You join a job, you do science, but science can also just be a thing, be a gig. You're an artist. You can join a studio to become a senior artist in that studio, but you can also just do art on your side. And science is at the same time a collective effort. You need collaborators, you need people to work together with you. So for that to happen, if you're taking science as a gig, then you have to be able to work with other people. But then we don't have really a culture there yet. Sort of if you analyze all the papers out there, Google people are working with Google people, CMU people are working with CMU people. Not exactly, but there are clusters, right?
Welcome to the Gradient Descent podcast. I'm here today with Lavanya, and we have as a guest Roseanne Liu. I'll say I am super excited to talk to Roseanne. I had heard of her good work at Uber for quite a while, but then she actually came by Weights and Biases to give an open talk about one of her research papers. And I was just so impressed with the kind of creativity in the way that she analyzed the neural networks. And we'll get into that talk with her today. But Lavanya, you actually found recent stuff that's even kind of maybe more exciting that she's working on.
Yeah, so she has founded this amazing organization called ML Collective, and she's trying to democratize AI to anyone. And she's trying to ensure, even if you're not tied to one of these super prestigious institutions, you can still publish really cool research. And that is just such an important thing to work on. So I'm super excited to talk to her. Welcome to Gradient Descent. I want to start with what made you found ML Collective. It's such an important organization. And as someone who cares about diversity and also democratizing AI, I'm curious about your journey.
Yeah, thank you. Thank you for having me. And thanks for saying that it's an important organization. I don't think we're there yet. We're so new and young that it can really go either way at this point. Like one wrong decision we make, you can really turn it to be a not so good organization. But yeah, so ML Collective is, interestingly, it's like a million things in my head right now, because as someone who runs a company, I'm sure, Lucas, you have the same feeling. It's like there's a narrative always in your head going like, what is this company I'm trying to do? What is this thing? And then you like little by little add ideas to it. And then at this point, it's just like so many ideas all combined together, basically representing everything I want to do in my life. One, research. I want it to be a research lab that people just do research together. There should be people better than me, ideally. And there should be people like better than me, but maybe less experienced, so I can offer help to them so it can feel useful. There should be a wide range of people. There should be people who like having a home, like I like having a lab feeling. There are people out there, doing things better by themselves, but we are really trying to attract people that work better with people collectively. So it's a research lab. It's also a nonprofit because I also want to do, charity. I want to help people. And I think one dimension of science should be done within nonprofit. I mean, we don't see a lot of things, a lot of science or in terms of ML research going on in nonprofits. There's mainly driven by industrial labs because they have all the resources. But I think if we can set up one small example to show great research done through nonprofits, that would be great. Then people can really open their mind when they think about their career choices. There's like one more avenue for them to choose. So Research Lab, nonprofit, is also just like a co-working space that people just come together when during their gap year, or when people feel like just want to dabble in science a little bit, or they're moving out of science, but they still want to get involved want to see what's going on in ML. So it does that. Yeah, it's also something very personal, something that sort of changed my life, but we'll get to that maybe later.
Actually,
No, let's go there.
Yeah.
Can we
Exactly.
tell us the story behind how you decided to create it?
Yeah, interestingly, it's such a big change in my life, like maybe the biggest change ever in my life. And now I just wonder if like every business, well, every change you see in someone else's life must be propelled by like a misfortune, because that's what happened to me. It was spurred by a misfortune. Basically, the whole narrative goes like this. So I was looking for a job. I was out of a job in first place, and I was looking for a job, and there's no job really that offers the things I wanted, a work environment to have. So we decided to build our own. So that's as easy as this. But you can imagine not being able to find a job, just feel like getting rejected everywhere must be very heartbreaking. And that's what happened to me. And feel like just everything went wrong during that period of time. But really like changed is a conceptual change in my mind that I feel like instead of changing myself, because what this signal out there is telling me is that I'm not good enough to fit the hiring rubric of all those places. So instead of changing myself, thinking I should be more and more like what they want, what I decided to do is just change the hiring system, have a whole system of my own where we get to hire people or recruit people differently from how they do it.
How does your organization compare to academic organizations? Because most academic institutions would be nonprofits too, right? Like, what's different about what you're doing?
Yeah, they're actually both. So academic can be profitable or nonprofit. They can be public and private. So we are strictly nonprofit, so we are funded by donations, basically.
Mhm.
When we are funded, we're not funded now. So once we're funded, we will be funded by donations. Difference with academic is it's not employment based. So everyone joined just as a member. They can have their own employment. That really gives people a flexibility. They can view this more like a hobby, which we found is actually motivates people more than when they view this as a job. Like they have to report, they have to keep track on like how much they're performing. They have to report to a manager, stuff like that. We function very much like academics because the key people in the organization are sort of like PhD. So that's like the only way we know how to run a lab. So we hold research meetings like a lab, like everyone gives updates. There's no graduation, so that's one difference from academic. It's not like you have to join and then 5 or 7 years later you graduate. It's really flexible. You get paid even less than academia, which is unfortunate. But until we got funded, we can adjust that. But now it's everything's volunteered. So
What are some of the challenges in building a sustainable nonprofit like the one that you're building? And not just monetary, but other challenges too.
I haven't made it sustainable yet. So I feel like I should be asked this question like 3 years later. Like, how did you make it sustainable? Or why did it fail? But I can see a little bit glimpse of hope there because we're starting to get donations and get fundings even without going into a full donation raising. We're already getting interest from big companies and personnel that wanting to contribute to the organization. So I feel like it's a different ecosystem, right? Like this like profitable world, they have their own ecosystem. Startups, they raise donations, so they raise investments, and they promise that there's certain return many years later. They give shares out. In this world, you raise donations because you're selling this concept, and you feel this concept is so important. It's going to have such a social impact that the donors or philanthropists they really buy into this idea. They want to do something back to the world. So there's like a whole different ecosystem going on there. Many nonprofits, as far as I can see, survive in that ecosystem. So I feel like we probably can have a shot there. I haven't proved it yet, but that's my idea. And also, a lot of donations don't come in monetary, as you said. A lot of people that are our current members, they're really just donating their time to work with us, right? They're helping others publish papers by donating their expertise at their time. That's actually way more valuable than money. And there are also donations of compute credits. AI research is expensive. We need all forms of donations. But yeah, when they all come together, I feel like there must be a model that is sustainable. I need to prove that, but I'm hopeful.
What kinds of research are you doing that you think might not happen somewhere else?
That's actually the best part. So as a nonprofit, you're not driven by goals or anything. It's not like you have to prove to someone that I have to make this object detection thing better than 98% or something. It's really just curiosity driven. So you can do anything that interests you. And we also, the management of ML Collective is not hierarchical. Like we don't have a central manager or of any sort. You can start projects any way you want, and you will be the lead of the project as long as you're a member. So it's really driven by individual members' interest. So that's the best thing. If you coming from a physics background, you maybe have something to do thinking about how physics is related to neural networks, you can do a project like that. You can tell people about it. People who are interested will join the project. Then you form a little team of your own. You will be the lead of the team of that project. You push it through. Maybe the next project you want to join someone else's because you want to learn something. You want to learn, I don't know, like how things work in brain. So you join a more like a neuroscience project where someone else is leading. You're more like a happy follower. So that would work out. So your role would be like very dynamic. Yeah, so the answer is like we're not limited to any specific topics. It's really driven by individual members' interests.
Could you tell us about some of the things you were working on?
Yeah, I think most of the things are published. We put it on a website. So looking at my own profile, I feel like I've always been someone in ML, but like just like dabbled around different topics because I like, maybe I'm not as patient as most scientists. I like just trying different things. And also neural networks, the whole machine learning is changing so fast that I don't think anyone can confidently say that the next year this is going to be the biggest thing, because like any, I feel like any breakthrough from any small field would become the biggest thing if more people spend time in it. So in the past, I've done vision projects, NLP. I have recently had an NLP project. The very latest project is about continual learning, but that's also an interesting concept that I like. We have projects about network pruning. Basically, like whatever's going on out there, we take a look, take the recent paper, look at their code, and try to implement it, run it, and find faults in it or find things that we didn't understand it and try to understand it.
So I feel like a lot of our listeners might be thinking this sounds like a great idea and a great place to get involved in. Do you have thoughts on who is your ideal person to join ML Collective?
Yeah, you can think of people as like different categories, but of course, every single person is always a combination of different qualities. But you can think of people who are really like the lead experts in a subfield. They really want to push that subfield forward, but they're lacking resources in terms of like people. Maybe they are a really senior researcher, but their job doesn't give them reports. I know for whatever reason they're not managing people yet, but they want to have their ideas executed. They want to influence people. So that kind of people can join as sort of like a thought leader. They can lead a project, and other people can join, sort of like work out research project that way. And there are people who are having free time and want to run code, want to sort of follow all those projects like led by those experts. Those people we're also welcome. But we're mostly welcoming people that are not offered the opportunity at the big industrial labs, because those people, if they can get into industrial lab, they probably wouldn't be interested in us anyways. But also, they're not the people that we're trying to attract, because all we want to do is to serve as a diversifier from the industrial labs, from academia. So the people that cannot be hired easily by them. So you can think of what kind of people they are. Probably they don't have a PhD, right? That's one of the biggest reasons that they don't have a resume that looks immediately hireable. They started coding since they are a teenager, but then they never really pursue a higher degree that way. But doesn't say that they're not a good researcher at all. Probably people who are changing fields, they have a PhD but in something else. They were trying to get into ML, and it's much harder for them to just immediately get a researcher's job in those labs. So we also accept those kind of people. Yeah, so basically we try to serve as a diversifier. Anyone who is having a difficulty getting into those places but still want to do science, like if they were in those places, then we welcome those people.
Can I ask another one before? You talked about diversity, which we care about a lot as well. And I feel like every company says they care about diversity, right? But what's one concrete thing that doesn't require a lot of resources that any company can do to get more diverse talent in?
Yeah, that's a really good point. I think every company probably cares about, there are people in the company cares about diversity, but then when it comes to what their main goal is, because a company, if they're making profits, their main goal is still to make the company run. Diversity becomes the like secondary thing or even third thing that they care about. And that's when things break down, because if you're going really just for productivity, for the speed of producing the next paper, then you wouldn't care about diversity. You would just hire the person who can quickly, the fastest, like produce a paper the fastest. So you really need organizations or institutions that put diversity as the first, first world citizen or whatever. Like that's our first goal. So nonprofits is sort of like the thing that I'm thinking about, because they are not going after profits, they're not going after productivity. They're not trying to submit to every conference because they want to show status. Their whole job is to help people, to level the playfield for people. Yeah, that's the way I'm thinking about it.
Well, I guess like I would love to hear more about some of the research that you're doing currently. I remember looking at your work on the loss change allocation to try to understand what neural networks are doing, and thinking that was such a cool idea. I wonder if you've had any chance to like follow up on that work.
Yeah, I remember giving the talk at Weights and Biases, and you asking very great questions. Back then, I didn't know that you were the running Waste and Biosphere. It was like, that person has great questions, but I didn't know that you're the founder and
Oh,
CEO,
that's
of
so
course.
touched. That's I appreciate that.
Yeah, I was just impressed by your questions. Yes, so that work is LCA, loss change allocation. So that was published in Europe's 2019, a year ago. Can't believe that. It was led by Janice, our resident back then when we were in Uber. So basically, the idea is that we can break down the loss change onto each parameters. So you can clearly visualize and see how much each parameter is contributing to the training of networks, just in the training sense. We're not talking about, validation or generalization yet. And surprisingly, you see that half of the parameters hurt the training, probably understandably because everything's so stochastic. We add noise into the process because we use stochastic gradient descent. We use mini batches, and we sort of like reduce the optimization to be linear. So all those are contributing to the noise in the process, but still the amount of noise in the training process was surprising to us. So the whole work was basically like visualizing all those, how many parameters, what percentage of parameters was hurting, and then break it down into each layers. And we found that some layers hurt more training than other layers, especially the last layer. So actually a very easy follow-up work would be, we propose that the last layer should use a different momentum term, and we did a small experiment there and show that it improves. So I don't know if anyone from then on, like training networks, were using a different momentum term for the last layer, but they should.
And this is basically in every single step, or is this over like a larger period that you see the half of the parameters hurting?
Yeah, so at any given time, there's over half of the parameters that are hurting, and then across the whole training, half of the parameters hurt overall. Yeah, if you accumulate all the contributions together, which when you add them together is the exact training loss from the beginning of training to the end of training. Yeah, so any moment there's half of parameters hurting, and then throughout the whole training, it's also over half. And also, if you track one simple parameter, the thing is that it hurts half of the time. So it's not really like if you can catch this criminal and then just ban it from making changes to the loss, because like they also jump around the hurting camp and the helping camp.
I mean, it doesn't seem surprising that and by hurting, you mean like the parameters, like they change in a way that makes the loss worse, right? Do I have that right?
Yes, makes the loss go higher.
And so it's funny, like it makes sense that in the stochastic process, some would be making it worse, but it seems so surprising that half, right? Because overall the loss does improve over the steps. So
Yeah, exactly.
what's going on there?
Things that we didn't understand, like many things in neural networks that we didn't, like we sort of get the idea, but then until we see the data, we're like, yeah, that makes sense, but still it's surprising. I feel like many papers are like that, and those are the papers that I aspire to write, like papers that you sort of have intuitive sense that this is something that's going on, but until you see the data, you're still surprised by the amount of it, or the actual extent of it. So yeah, I don't think we understand.
That's so cool. I wish you had a chance to follow up on that. Do you running an organization, do you find yourself, maybe this is asking for a friend kind of question, but do you find yourself spending a lot of your time on more kind of administrative tasks and recruiting and things like that than actually doing research?
Yeah, exactly. I started to doubt whether I'm still a researcher, because every day I look at my time, I'm like spending half a day designing a logo, because we need to have a logo, and just like no one's working on it. And then the other day, because we're organizing an event, I'm just spending all my night designing a gather.town like layout. I'm like making houses, making rooms, make sure people can go to different rooms and things. Yeah, there's so many administrative things. But that's also one of my goals. Like I feel like, honestly, the next 10 years, I feel like publishing papers wouldn't give you so much value as before, because there's so many people trying to publish papers. What would give me more reward is actually helping people publish papers. And a concrete goal actually of mine is just end up in people's papers acknowledgement section. That's all my goal. I'm not trying to be a co-author anymore. Just because, I don't know, I don't think it's a field that I want to be close to, of course, publishing. I want to publish as much as I can, but I also want to remind everyone that the publishing scene is going to be very different the next decade, just because you see this huge influx of people coming in trying to publish papers. Almost every idea has been chewed over 1,000 times. It's so hard to come up with an idea and then search the literature, find out, oh, no one has ever done that. It's impossible. Someone is doing that somewhere. which is to say that researchers right now, ML researchers right now, are having a hard time. If I can help them a little bit, help their paper, improve, or be different, and make their success rate of their paper getting noticed or published slightly higher, then I'll be very happy.
I guess what general advice would you have then to someone that's trying to get something published? Like, what are the mistakes that you see first time people or outsiders make, and what kind of help do you typically give to someone?
I feel like the thing is that our reward function is delayed, right? So we go into ML research liking it because we saw other people in research maybe like a few years before us, and they gained reward out of that. They published a paper and it was so recognized, and they have such a fame and recognition and everything. So we want to do the same thing. But the difference is we live in a delayed timeline. So when we get into it, the scene already changed, but we don't know. So I really want to remind everyone that if you're getting into ML research now, publishing is very different than before. Before, if you have an accepted paper at, I don't know, iClear or NeurIPS or CPR, you're basically you're there. You can probably get a job that you would want, get a dream job, get a position of something, but not anymore. So now I think the next people will be looking at citations. Even if you get a load of paper published in peer review conferences, people will look at different metrics now because there are so many papers getting in and so many people having their papers getting in. So yeah, the basic suggestion or like advice is that you should try to adjust your reward system to be different from what you came in the.
Should you adjust it too?
That
I
makes
mean,
sense.
you're saying, I mean, it just seems like you should just make things even harder for yourself, right? Like you can't just publish a paper; it has to get citations. Is that a good summary?
Yeah, so no, that's why you should be looking at other things. You should be really just looking at love of science. I want to do this for the love of science. I'm not trying to. I do this piece of work not to. Well, if it gets published, that's like a confirmation that is a good science. But the basic thing that's important is that it's a good piece of science. I think that's what I want to say. You can do a beautiful work, put it in an archive. Don't worry about whether it gets accepted or not, because there's so many noise in that whole thing. The same as neural network training. There are so many statistics that the same paper with no change, just submitted to 3 conferences, get rejected, accepted, because it's just random chance. Every time you're just drawing a lottery ticket of some sort. So don't care about that. Don't care about really the true acceptance or not into a conference. Really care about the quality of the science you put out there. Because if it's on archive, you have your name on it, it's gonna, that means something. So like change your reward system to really care about the true quality of science, and remind yourself that you're in here for the love of science, not for, of course, some people are in here for too, so that it promises a better future, and there's nothing wrong with that. But those will probably, stray you a little bit away from the path, and maybe make you a little bit miserable.
So, what's the
we
key to
already are.
doing good science as an outsider? Like, how do you do that?
Yeah, that's actually the idea of running ML Collective. I feel like there's so many problems these days in the world that people don't believe in science, right? I'm not saying ML Collective is the way to change that, but I sometimes think if you can get everyone, not even everyone, like the majority of American, to publish one paper in their life, maybe they'll just believe in science more. Like once they go through that publication process, they see like, oh, to put this statement out, I need to try everything around it, do ablation study, compare with all the benchmarks. So they will become more careful when they put statements out. I don't know. This is a weird argument I'm making, but I feel like if I can get more people to do science, not for life, just like publish one paper in their life, I think everyone's attitude towards science will be better. They will believe it more. We probably wouldn't have all those problems out there in America that people don't believe in science and other things. I don't know. That's my dream, of course.
That's a great idea. Also, I want to address the other end of the spectrum, which is all of these people who are trying to keep up with all of the papers that are coming out. And maybe you can use this opportunity to talk about this amazing paper reading group that you've been doing for like 3 years now. So what's your advice for people who want to keep up, and what kinds of papers should they pick, and how should they go about reading them?
Yeah, there's no better way actually, because I think this is like our first time of facing this problem. So there's no historic lessons that we can learn from it. That this like huge influx of paper. For now, I still trust those that published at peer review conferences, but we know that there's a lot of noises in there. But I trust it slightly more than papers that just put on archive. I sort of have like a general sense. So there are many people like me out there running paper clubs or YouTube channels, like they dissect papers. Each of them, of course, has their own criteria in judging papers. But if you accumulate more of them, sort of like they average out to, I think it's representative of the overall quality. Yeah, I think like a shameless plug. I think I'm not. I think I'm by now I'm a good discriminator in all those subfields of ML. By being a good discriminator, I mean like I can sort of judge like what's a good paper, what is bad. I might not be a good generator in all those subfields that I never published in, but being a good discriminator is the first step of feeling like I can run this thing. So you can sort of trust the papers that I selected, but then you have to remember to accumulate it with all the other people's selection, so to get a more balanced view.
Could you give us a little window into your process for being a good discriminator of high quality papers?
Yeah, I just read a lot. Some basic elements I feel like a lot of papers are missing. Maybe they're the people that are coming into ML research from different fields or from a non-researcher's background, which is again like why I feel like ML Collective is important. Get people into this paper publishing process and tell them like what are the basic things you have to do. Compare with baselines out there. Try different variations of the method that you're proposing, and that's ablation study. I see so many papers out there that have like huge diagram, right? Like signal goes in and then there's like so many branches of things and they branch out and then this is the end result. And they say that this whole system works much better than existing systems. But that's not science. That's a good engineering. Great that you made it work, but what does it teach us, right? Is this branch more important than this branch? Like why did you branch out this way other than that way? Is real good science work should be, I think, inspirational rather than intimidating. So that huge diagram is just intimidating. It's like I built this huge thing, it worked. I'm not going to tell you how because I hacked them together and it worked. Maybe there's scientific value in it, but to be a good scientific article, you have to tell us, what things you have tried, why this branch other than that branch. Did you do ablation study? Did you try to turn off this branch? What was the thought process behind it? How does your work inspire other work, maybe in different fields, to borrow the same thought process to produce their science in their subfield.
Do you have a favorite paper over the last few years that kind of exemplifies this of like, a simple difference and then like a clear insight?
Yeah, there are many amazing papers out there. Am I allowed to say my own?
Oh, absolutely. Absolutely. Yeah, tell us.
Actually, really
which,
like
I guess,
early.
Which is the paper that you're most proud of?
I actually really like an early paper of ours called Intrinsic Dimension. It's many years ago, not many, but in machine learning, it feels like many years ago. It was published at ICLR 2018. Yeah, so intrinsic dimension is basically you take all the parameters. I know, but it feels like forever, right? That's
amazing.
That's nowadays when you look at papers, you're like, this is 2018. Probably there are better works than this, so I shouldn't be reading this paper at all. But yeah, it's only I think that's only 2 years ago. So that paper has to do with just measuring this basic property of a neural network. So neural network has so many things along associated with it. There's parameters. There's like a large parameter counts. So if you imagine putting every parameter just together into a big vector, it's just a super long vector, and then you reduce it to a shorter vector, and you only train the shorter vector. And how do you map from the shorter to the bigger? It's just through a matrix. It's a linear mapping back to the big vector. So basically, you're saying that even though this network has 10 million parameters, maybe the dimensions that you can make changes is much, much smaller than that big number. And there's a number out there that's much, much smaller that says something about your network, combined with your problem, combined with your data. That's how easy or hard this network combined with data and problem is. So that becomes a measurement.
Sorry, so you can actually do that kind of, because that's going to be a lossy compression, right? Like you can actually do that, like make it much smaller without hurting the performance?
Mm-hmm. Well, I think now it becomes not surprising because now you can prune. So pruning is like that. It's a axis aligned reduction, right? You reduce big vector to a smaller one by basically masking some of them as 0. But back then we were just doing a linear projection. Yeah, you can totally do it because a lot of parameters in neural networks are redundant. Not that they're not useful. Well, LCA also teaches us that. Not that they're not useful. They provide a better or different loss landscape for you to train, but you can definitely train it within a much smaller landscape. Well, if you think about it, this huge landscape that all the parameters help construct leads you to an endpoint where there's better loss. If you can draw a line from the endpoint, from the starting point to the endpoint, that's just one dimension. If you can just travel along that line, that's an intrinsic dimension of one. So any network would have a dimension of one that is trainable, but that one is very hard to find. That's almost just like very singular. So this intrinsic dimension is saying this amount of dimension, however you draw the line or the plane, it should still lead you to a good enough solution.
Wait, but how could you take because you can pick the linear function that goes from your sort of like simplified representation to the more complicated representation.
Yes. So the thing is, if you were allowed to pick the linear function, you can reduce the dimension to however you want, down all the
Right.
way down to one. But that's not what we want to measure, because that's just like one for every network. What does that tell us? So the things we want to make the projection matrix randomized. So then we measure how big it is. Because you know that in a very, very lucky scenario, this can be down to one.
Mhm.
With that knowledge, you should know that by just randomize it, there should be a number that's larger than one, but should be smaller than the super big vectors to start with.
I see. And so how much smaller can you go? And is it like suddenly there's a drop off at a certain size, or is it sort of like a smooth deterioration of performance?
Yeah. So back then, basically you have to try every number. So that's more of a science investigation. It's not something that can help you, train the network faster. Because basically you have to try every number from big to small, to small to big, until it crosses the threshold, whatever threshold you want to be. So we pick a threshold that is 90% of the full network performance, or you can do it 99, you can do it 85. It's up to you. So pick that number. And that number is interesting. I want to make sure that I remember the number, so probably I wouldn't. But like for MNIST plus FC network, I think is 750. It's much lower than 784, which is just the input dimension of MNIST digits, which makes sense because there are many black pixels in MNIST input digits. But like that number is very interesting. And then for CFAR, I think it's like 19,000. So that sort of gave you a sense, CFAR is harder than MNIST, but how much harder? Probably 10 times harder.
But isn't
something
this
like that.
also
Sorry, 19,000 is
dependent-
probably the...
Sorry, you're
Yeah.
modifying the network, or are you modifying the input?
You're modifying the training procedure. So once you pick a network, you pick a task, data is there, network's there, initialization is there, then your loss landscape is fixed. Now you're modifying the training procedure to let the point move not in any direction, but in a restricted plane. You can think of it that way. So you're modifying
So
the
you're
training procedure.
And the training procedure means you're like first modifying the input data, sort of shrinking it before you put it into the network? Or you're only allowed to change these smaller set of numbers, and that changes the network through a linear transformation. That changes the parameters. So then how can you say like MNIST and CFAR, wouldn't it matter also the network that was being used? Like, wouldn't a bigger network maybe have a different...
Exactly. That's very true. But what we found interestingly is that for at least in the scale of our experiments, MNIST plus FC network, fully connected network, you can make the network bigger, wider. The number is roughly the same. So 750 was the number we got from MNIST plus FC type of network. Of course, if you make it huge, probably the number will change. But to the extent that we vary the size, they're sort of stable, which gives us confidence that it is a stable measure. But then if you change to convolution, it changes drastically. It reduces, as you can imagine, because convolution is a much better landscape. It gives you a much lower intrinsic dimension. So it's the same story when you switch to CFAR, when you switch to other tasks. You can also do RL with it. So that's the interesting part. You can finally compare RL tasks with computer vision tasks, which people never really do, because people doing RL sort of know that, okay, this... I don't know, Pong is harder than some other game that I don't really do, or else I don't know. But then, and people doing vision knowing that MNIST is easy, CFAR is harder, ImageNet is much harder, but then they don't make this parallel comparison. But now we can. Of course, it's not a very strict comparison because they are using different networks. But we find that some games are much easier than you thought. This carpool game has only a dimension of 4 because probably like you just need to move in 4 dimensions.
Even though, what are the inputs into the carpool game? There's not that many inputs, right? It's just the
pixels.
Angle of the... Oh, it's pixels. Oh, I see. From the pixels, you can see that.
They're actually pixels.
Oh, cool.
Yeah.
Oh, that's so cool.
Yeah, but it's an old paper from 2 years ago, 2.5 years ago.
A decade ago sounds like the way you talk about it, how much time has passed. What are some of the practical applications of this? Like, could people use this to maybe take their networks and deploy them on mobile phones and other applications like that?
Yeah, it's a very interesting question. So back then, when we were doing it, we sort of claimed in the paper that this is a scientific investigation, but there are some implications of reduction, like because the whole matrix is randomized, so you can just save one randomization random seed to regenerate that whole matrix. So that and then you train in such a small dimension, so the whole memory usage is much slower. Much smaller. But actually, speaking of like this year, NeurIPS, which is coming up next week, there's a paper published there that actually took the idea that we had 2 years ago, a long time ago. They actually make it more useful. I think it was their method. They like make a few tricks in the algorithm. It's no longer measuring this intrinsic property of a network anymore. But it becomes a better training method that I think they're able to train in such a sub-dimension better networks or faster or like with all those memory save. So yeah, check out that paper and this year's NeurIPS.
Okay, cool. Yeah, we should put notes. We should put in the show notes both of these papers.
Random subspace training, something like that.
And I guess you're also doing something at NeurIPS this year on open collaboration. Is that right? Can you say a little bit about
Yeah.
what you're trying to do there?
Yeah. So that's the whole thing with ML Collective, right? If ML Collective is about one thing, it's about open collaboration. We want people to think that science is not. It's not like science can be associated with employment. You join a job, you do science, but science can also just be a thing, be a gig. You're an artist. You can join a studio to become a senior artist in that studio, but you can also just do art on your side. And science is at the same time a collective effort. You need collaborators. You need people to work together with you. So for that to happen, if you're taking science as a gig, then you have to be able to work with other people. But then we don't have really a culture there yet. Sort of if you analyze all the papers out there, Google people are working with Google people, CMU people are working with CMU people. Not exactly, but there are clusters, right? And there are each of us sort of like bears our own comfort zone of collaborators. We sort of like rarely go out of the comfort circle because it's with any new people it's like there's a friction of working together, so we don't do that too often, and that creates a problem because like we're so just also little bubbles isolated, and new people find it really hard to join all those circles. At least as a new people back then, I find it really hard to just like find someone and become their collaborator because there's not a culture like that. So the whole thing with ML Collective is that we have members coming from all different kinds of employers. They are work elsewhere, but they're willing to share their work within ML Collective. They feel this is a safe space that you can share your work, get feedback, maybe become co-authors with people you never would have because you work in different teams, different institutions. So that's the whole idea. There are many people sort of are carrying this culture around. That's why we invited all those great people to the social, talking about how they have done that. So people that are holding office hours, like actively outreaching to people, trying to mentor people on their spare time. There are companies that entirely run science in an open way. They broadcast all their meetings. They put everything out there on GitHub, like even the like everyday commit of codes out there. So there are many open cultures out there. So we want to gather people sort of to discuss, the pros and cons of this method. Of course, science is much slower produced this way because you have to uncomfortably work with people that's not familiar to you, but it really improves the whole overall well-being of the society. So yeah,
It might not be
social
slower.
is
It might be faster if you make more connections in the sort of global brain. I could imagine that it leads to
yeah, I don't
more
know,
interesting
but then
insights.
there must be a reason that people are not doing that a lot. I feel like it must be slower in the case that there's always this friction period that you're getting to know each other, what each other's work style is like. Yeah, I don't know. I feel like people have tried that so little, must be out of this like fear of how hard it would be to work with other people
Well, I would think people might
all
just
of a
feel
sudden.
shy. It's hard to go meet a stranger. Do you
Yeah,
do you do
could be
anything to
that.
sort of like facilitate just like getting people talking to each other?
Yeah, so for now we start this organization where people just join from anywhere. So I'm sort of like the hub. I know everyone, but they don't know each other to start with. But then if you do biweekly meetings like we do, we talk about research every time. And then you two can be commenting on the same graph, and then you're like, oh, we're thinking the same way. You're like-minded people. We should talk more. Then they can talk offline. Then like I'm done. I'm like a matchmaker, sort of like link people together. I'm very happy if like two people that didn't know each other now work together. I feel like my satisfaction comes from that.
It's
Did you have a question?
fascinating. Yeah, it's fascinating to me that you're taking the credentialing aspect out of like these research labs and almost replacing them with collaboration. Is that the reward function, or is there a different reward function now?
Yeah, the reward function for me is definitely just, yeah, if I can reduce the whole thing ML Collective does to one metric, that would be the number of new collaborations formed. That would be my reward function. That's the reward function of MLC. But my personal reward function, as I said, is how many papers that have my name in the acknowledgement. That would be my near-term reward function. I'll be very happy if like people thank me in their acknowledgement.
That's great.
What about for the researchers in MLC? Like, what's their reward function, do you think, and how is that different from those people who are working at traditional labs?
Yeah, so curiosity driven, that's one. We're not goal driven. We're not trying to beat any benchmarks. We're allowed to do that. I mean, like other labs probably also have some elements of that, but yeah, I don't know. Each lab has its different culture. Some are more open, some are more goal driven, like trying to make sure, like the whole thing that people talk about on Twitter is like, I have 28 papers in this conference, so we would not be saying that because we can never reach there. But also, that's not our goal. Like, it's not got get this number of many papers in a conference. It's more like we can have this scientific discovery purely driven by curiosity, like the intrinsic dimension paper. It was just us thinking, everyone trains neural network this way with the big vector. Can we train it with a small vector? It's like no reason why we have to do that, but we just thought about it and we think must be, right? Because thinking like if you can draw a line, there is a dimension one out there, but like how hard is it to find that dimension? How hard is it to find that even with a random initialization? So yeah, I would if I were to control it, but again, I don't control the directions of research in ML Collective. But if I were to control it, I would encourage everyone to see it as a fun thing. It's like ML researchers these days, they're so miserable. I mean, I was part of them, so I know that. Like every day, they're like, "Oh, this conference is coming up. I'm not submitting. I feel so bad. I'm such a failure." So really, I just want to make this a fun thing, a gig that they're doing. They get to meet new people. They get to work with people different from them, better than them in some ways. They get to feel like they're helpful in others' projects. Yeah.
I think it might be eye-opening for people listening to this that someone as successful and credentialed as you could feel like a failure. Like I feel like it's an occupational hazard of the field, but I really do think most people listening or watching this will be surprised to know that.
Oh, exactly. So much. I didn't realize it because it's not so miserable that I'm just, crying every day, but it's this like a mild level of depression, which is the worst because every time you confront it, you're like, I feel bad, but should I be feeling bad? I'm having this amazing job and I get to do science, in an industry getting paid like reasonably well. So you sort of counter yourself of the bad feeling. That makes things even worse. So from the outside, everything is glamorous. I get to publish every now and then. But yeah, I was miserable. And I realized one key thing that changed my mindset is that I was just viewing everyone outside of my team as competitors. And I'm just miserable because I feel like I have to compete with them. And if they're publishing 28 papers and I'm publishing zero, I'm losing. But now by running MLC, I see them as collaborators or potential collaborators. So people are out there. If we have the same ideas at the same time, the past me would be like, no, I'm scooped. But now I'd be like, great, that means that's a great idea. You can be my potential collaborator. I can talk to you and you can join MLC and help me and help others. It's really like a mindset change, at least for me. Or maybe just because I'm not getting paid right now. So if you let people do something and then not pay them, they start to think that this thing must be noble because I'm doing it and not getting paid. I don't know which aspect is the one that changed my mindset to be from that to this. But yeah, there are many things that has changed.
Well, I have to say, I really admire you creating the world that you want to see. I think that's super admirable and impressive.
Thank
We
you.
always end with two questions, and I want to make sure we have time to do that. The sort of second to last question that we always ask is, what is something in the like ML field that you feel like it doesn't get as much attention as it should?
That's a good question. I would say understanding of things. I think the field of ML research publishing would become healthy if we start to see a wave of papers that just go, I picked this little concept, batch norm or dropout, and I studied so extensively that I wrote an 8-page paper out of it. I tried everything I can, like with it, without it, in this network, in that network. And the end result is we didn't find anything amazing, but we understand this concept 1% more. 'Cause that's science. I want to see a wave of paper that's written this way instead of we beat this benchmark, we beat that benchmark, because that's very rare. Just like trying to go for a deeper understanding of one small concept, see like why it helps. And there's so many things we don't understand in the way that we train neural networks. And of course, people, when you say understanding, people have different comfort levels in terms of understanding. I can see like there are people out there having more of a hacker's attitude. They would think they understand something if they watched a 5-minute video of it, right? They're a more like humble, conservative attitude, which I would say like more of my scientist peer have, that is, unless I published a lead author paper on this subject, I can't say I understand it. Like even if I publish one, I can't say I understand it. So there's different levels of things, but I hope people are going for a better understanding of things than beating benchmarks.
And I guess the last question is, what's the biggest challenge of publishing a paper independently when you're not living in a big lab?
Oh, there's so much of it. The lack of resource, the lack of support, the lack of people just telling you it's a good idea or bad idea. Lack of discriminators, right? When you're publishing a paper, you are the generator of the paper. It's like lack of discrimination. Think about GAN training. Without discriminator, you really can't train a good GAN. Yeah, all those things. That's why we want to recreate this great graduate school lab experience for everyone. You don't have to join a graduate school lab. You don't have to join a big industry lab to have the same experience. Like mentors or collaborators, peers, people just say awesome on your plots, or like, yeah, you should add one more line to that plot to make it more awesome. Stuff like that, right? People you can bounce your ideas off of. Yeah, all that little things. Of course we know how hard it is for individual researchers to thrive out there. Yeah, if ML Collective can help them a little bit, I'll be very happy.
And I guess I'll sneak in one final question. If people
Great.
are listening to ML Collective and feeling inspired, what's like a next step for them to get a little more involved or learn a little bit more?
So for a nonprofit, we really want to get this idea out. Is this social impact we want to put out, and the idea for us is the open collaboration. So for people out there, if you're a researcher, if you're an individual researcher, independent researcher, you can always come to work with us. There's many collaborators that here are, will be happy to work with you. If you are already a senior researcher, an established researcher, you should like think of this concept actively every day. Every paper you should think about, did I help someone with this paper? Like, did I just work with the same crew of collaborators that I always worked with for the past 10 years? Or did I put someone new on this paper and really helped their career? Because having a paper helps so much in someone's career, at least for now. Did I try to make the world better with this paper? Like, aside from the scientific pursuit, of course, you're making the world better by just, putting a scientific work out there. But did I give other people chances to work in science? Did I help someone underrepresented or help someone from a non-traditional background get into science through this paper? Yeah, I want to get people to think about this question actively.
Awesome. Well, thank you so much. Real pleasure to talk to you. Thanks for taking the time. That was a lot of fun.
Yeah, thank you so much, Lavanya and Lucas.
Thanks for listening to another episode of Gradient Descent. Doing these interviews are a lot of fun, and it's especially fun for me when I can actually hear from the people that are listening to these episodes. So if you wouldn't mind leaving a comment and telling me what you think or starting a conversation, that would make me inspired to do more of these episodes. And also, if you wouldn't mind liking and subscribing, I'd appreciate that a lot.